Boris Tchikoulaev. Did I say it right? Tchikoulaev.
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 Yeah.
Boris, definitely last but not least.
Yeah, thank you. Thank you very
Thank
much.
you so much for your patience. Sorry for the delay. You have the
So it's
remote
here?
there. Yeah, here.
Okay.
Just so that you all know, we'll be sharing all presentations and videos of all sessions with all the participants, subject to your approval, of course. So I'm going to be checking with you all. So this somehow will compensate the fact that some people had to leave before, couldn't assist.
Sure.
Okay. But the information is going to be sent out to all of them, eventually even available on our website shortly. But I'll be in touch. Okay. Thank you.
Perfect. So, hi, my name is Boris, and first of all, thank you for all the presenters today. I think we discussed really interesting topics. I'm here to present one that is especially close to me, to myself, as I act as a project manager and architect in different projects, data science projects in different industries, which is to present our data science process and how to operationalize more on a project management level here. Okay, so I'll be presenting our process, and I will be incorporating it into a practical use case. I think it's a more friendly way of doing it. I think we all are aware of IT project risks, and speaking of data science projects, we have some specific risks which come from the nature of the projects and the field itself. So it's a high-risk project by nature. Well, speaking of on commercial purposes data science, not on the research data science. So basically what we're trying to achieve here is to merge two different fields, one more of scientific field, which has completely different expectations, a process, and the expectation in terms of the outcome is completely different from business departments, right? So data is never, or usually is never, what we expect. Business goals might not be really realistic. So we have these exploratory and trial and error tasks, which are part of the nature. And we don't really want to eliminate that because we don't want to lose this value that comes from these kind of tasks. We have endless options, as we saw some examples today. And so on, okay? So even the final product, even if all of these points, they come together into to a great product, it might not be accepted or used by the end users, okay? So how do we tackle, and I'm going to present some suggestions and present the way we are doing it at Xpand IT. As a summary, we have our process here. And it starts with the viability analysis phase. And the viability, it's a strong term. And it's exactly the first step to merge these fields that I've mentioned. So the scientific field has a different process in terms of how to incorporate all the stages. And actually, we are pretty comfortable in the scientific field with a null outcome, right? So we may be trying and testing back and forth for months, and in the end, we don't really have anything special for the business, right? So the viability analysis phase is the first one, and the term it's used on purpose. Then we have several iterations, usually in terms of modeling, okay? And in the end, we have the deployment and maintenance part. This is very summarized, and I will describe it and go into some details using our practical example. Well, as a quick note in terms of the team, so usually on a project we will have the decision part, the coordination team, and the implementation team with different roles. I would like to highlight some of them. So the product owner in terms of the decision-making team, which should be a person or a team which guides us and actually makes all the decisions in terms of which path or which scenario should we approach and how, okay? In terms of coordination, usually we should have someone from the business team or the IT team acting as a subject matter expert. And just a highlight here in terms of the implementation, we should really involve someone from the business in terms of the implementation, okay? So So I'll be presenting here a road traffic prediction. It's a very simple use case. It will serve you to guide through our project process, okay? So very briefly, the business context is that we have a toll and we have information from the toll and we want to predict the traffic flow and eventually optimize some of the company's processes. So the first phase, viability analysis. Once we started doing projects a few years ago, of course, we've implemented and we've looked into the CRISP-DM process, which is the cross-industry standard for data mining. And what we saw is that it's a bit outdated. It doesn't really fit our needs. And basically, we iterated and we iterate several times. And it's actually a continuous improvement process. But thus, you are seeing some terms that come from the CRISP-DM process. So business understanding, data understanding, and here are some critical parts. We should start right from the beginning, identifying different scenarios and establishing success criteria and risks, okay? At this first stage, we might not have all the details, but a high-level description of success criteria, for instance, it's better than no criteria, okay? And we can try to define these goals for the entire project, but usually what we've seen is that we are only able to define it for the next iteration. And it's okay, I think. It's better than nothing again. And it actually fits quite well in our agile methodology. In terms of the deliverables, and once again, this is summarized, we will have some kind of business description report so that we are sure that the technical team is aligned with the business team. Data description and quality report. So this is the critical part and where we spend most of the time in this first phase. And then we will describe the opportunity scenario. So looking at the data, looking at the goals, what do we think that we can achieve and how, okay? And for each scenario, a plan for modeling, and we should start discussing right from the beginning how are we going to present this, what is going to be the deployment plan, okay? So it's a detail, but it's an important one, and we should start, even if we don't have all the details, once again, in terms of what kind of deployment are we going to use, we should definitely start right from the first phase discussing this with the end users and the business team, okay? So very quickly, business understanding, I'm not going to get into much details here, but of course we need to understand if there is a current solution for the problem or problems that we are trying to solve, and some, well, regular and usual business questions. So for our road traffic prediction, we have a current solution which is basically a manual prediction using previous seasons. And our goal is to extend this using some machine learning models and improve our initial and current solution. Success criteria. So, well, we have a couple of examples here, but of course, this depends really on the context, on the customer, on the project, on your creativity as well. But it's important to try to establish, because this is a critical part in terms of expectation management. Okay. So in this case, we will try to obtain a better prediction than the current solution. It's a quite obvious success criteria. Data understanding. So. Here we have, this is the critical part. It's looking into the data itself. And, well, we're actually building our own toolkit to help us accelerate this, a Python toolkit. And the goal is of course, to make a profiling report on the data, check what kind of history we have, does it fit with the business goals that we're trying to achieve. In terms of our practical use case, so we will have a easy pass, a toll information, and we will have meteorological information and some holidays as well. So we have 7 million records, 7 years period. At this stage, we are still at the first stage at our process. We are starting to formulate some hypotheses. And is this a time series problem? should we approach it as that? Data profiling, as I was saying, we can use some existing libraries, we can use existing tools. We are creating our own functions and methods. In this case, it's a regular data set, it's a public one. So we have some missing values, some holes in the timeline, but it's okay. We are going to move forward. We have several options, and the data it looks okay. Then we have the exploratory analysis, and we are still at the first phase of the project, and here is where we are going to start formulating different hypotheses. Okay, so we have the statistics over the data, or the different data sets that we are working with, and then let's try to explore it. Here, this is the part where we can chase some rabbit holes and just explore without any practical results, okay? And we might feel sometimes lost, okay? We're just exploring data for days or for weeks. But if we look into the high-level process, we know exactly where we are, and we have an estimate, so we have a time box to do this, okay? So although we are lost exploring data, we actually know where we are and how long are we going to do. So it will help us to guide and to manage expectation as well. So here we should start identifying opportunity scenarios to discuss with the product owner and the entire team, and starting to have a modeling plan. Okay, so at least the first iteration of our modeling will look like this, and we will have these goals. And at this stage, we should start defining it. So looking into our data set, we start to see that it's quite seasonal. It has some holes, but it's quite seasonal. Looking at the weekly data, we can clearly see a different pattern for the weekends comparing to the weekdays. And in terms of the daily hours, of course, we see the rush hours in terms of traffic volume. Comparing weekdays and weekends, we see different patterns for our rush hours. And starting comparing different and external data sets, the bars represent rain, precipitation, and the lines represent traffic volume on Sundays, on different Sundays. So different lines, it's different Sundays. And basically, we can see that there's a shift, there's a relation between the levels of precipitation with the levels of traffic on Sundays. It makes sense, it's quite intuitive maybe, but we are actually seeing it in our records, in our data, and validating it. So it might be actually something that won't result in nothing in the end, but at this point, it seems an interesting hypothesis to follow. Once again, and actually the charts here, they're quite technical, so we didn't really work in terms of the visual part. Here we can see the thin bars, the snow level represents the snow level, and once again, the blue line represents the traffic volume, and we can see that there's a relation. The more snow, the lower the peaks in terms of traffic. So at this stage, we explored our data. Okay, we might be using Python or any visualization tool or both. And basically, we try to formulate our hypothesis and identify attributes of interest here. This may seem quite intuitive for the use case, and that actually was on purpose, of course. But besides intuition and business knowledge, we already checked the data, and we are at least quite comfortable or minimally comfortable to explore and to move on with some of the hypotheses that we tried. The conclusions in terms of viability analysis. First of all, is there any business goal that is viable to pursue, right? Because there might be cases that it doesn't really make sense to move forward and try to model. And if we do have some hypotheses, we should establish different scenarios. And for each scenario, different risks, advantages, disadvantages, and present it to the stakeholders, to product owner, and so on. And what we are going to do, and it's quite usual actually, we will use the first iteration of our modeling phase to create a baseline, okay? Which is something like an MVM, a minimal value model, okay? So a very naive one, which will serve as a benchmark for all the other iterations. And then we will have several other iterations. We might define at this point how many iterations or leave it uncertain at this stage. We will use a different algorithm, a more complex one. In this case, the Prophet algorithm, which is a Facebook algorithm for time series. And here we conclude our viability analysis, one of the crucial parts and the phases of our process, and we start modeling, okay? At this stage, we'll definitely have data preparation and once again, a bit of exploratory analysis, and we may be going back and forth in terms of EDA and data preparation. And then we will proceed with modeling, so creating machine learning, optimization models, and so on. In the end, we will validate, evaluate, work on the explainability if we need to, and so on. Deliverables. First of all, first iteration, we will deliver a benchmark model, a baseline. We will have some conclusions in terms of hypotheses, okay? So maybe we can present 10 hypotheses and only pursue 2 of them, okay? It's something that it's usual. And we will move to our modeling iterations. And once again, the artifacts of our evaluations and validations. Okay, so first iteration, we will build a naive model, perhaps representing a current solution the customer or the department has. So we will use the last year's replica. Well, the idea here is to have a really quick development. We will not spend too much time on optimization. That's the whole idea. And then in the next iterations, we will use different algorithms. Perhaps we will try different ones. We will include different external factors, and we will compare all the results. Okay. So the first iteration of modeling, we will just copy the last year's replica, and we will try to assess whether it's a valid or model or not. So it's, well, I'm not sure if you can get it, but it's actually quite a valid model. We're not, so the blue one is the real observation and the green, the forecast. We're not really getting all the peaks that we have in the real observations, but it's actually quite okay. Looking only at this chart, so I'm summarizing it. At this point, we might figure out, or we might define that it doesn't really worth pursuing or continue pursuing this scenario or this goal, okay? Because the baseline, the simple model, it already fits our needs, and it doesn't really make sense to pursue it and spend more time on it. Modeling iteration 2, we will start including different external factors. We will start using a more complex algorithm or several algorithms. In this case, we are including snow, so we are starting to figure out and to predict the different peaks, lower peaks. We will try to incorporate different external factors. Rain, once again, it has improved our model. We're not really getting some peaks, but actually the snow model did. Temperature, the same thing. Okay, let's go to the third iteration. It makes sense. Let's just include all the external factors that we are analyzing and include the holidays as well. And we can see somehow, I hope you can see the green line, which is the forecast. It's actually matching and predicting quite well the blue one, which is the real observations. And it's better than the red one, which is the first baseline modeling, which is actually our success criteria. So conclusions, our success criteria are met. Of course, the last model, in this case, it's the best one, and we should stick with it. And here comes the deployment part, and I'm not including them, well, actually, it's a subphase here, maintenance. I'm presenting this more of on a waterfall kind of project. It's not, okay, so at this point, we might go back to some to modeling or to actually to the first phase and restart some of the scenarios or include more data sets. Okay, here we have the deployment, and it was something discussed previously today. Should we use batch or real time in terms of scalability? What we are going to do? So these are actually questions that we should start asking right in the first phase of our project process. In this case, I'm not going into much details, but we could use a Flask server and provide some API. So the outcome, of course, we've managed to predict well what we were trying to predict, and well, in this case, we could, for instance, optimize our resource allocation, or just having better insights and as a decision support system. So as a conclusion, these are just suggestions. That there isn't any magic formula, and the process isn't actually one-size-fits-all projects. It's just a guideline that we have internally, and even if we are not using the process itself or parts of the process, we know why we are not using, and it helps us just organizing the projects. And well, these are our suggestions. So thank you.
Good morning, everyone. Welcome to Insights 2019. Last year was a tremendous success. This event is planned to be better, so I hope you enjoy it.
Data is not just improving our gadgets, but is unraveling the way our society has been organized for the last 200 years.
We have representatives from all sorts of entities, companies, public and private sector.
Data science is one of the big challenges that we need to achieve.
The data and analysis only has value if it changes decisions.
Can a doctor that specializes on using data science techniques, can he become a data scientist?
Algorithms will be truly intelligent.
A lot of the models are built on our behaviors. We can create something. But should we?